Hey everybody, I'm eager to get started on Lab 1, but we need to go over some theory first before we before we get started. Otherwise, there's not much to learn, and there will be a lot of fumbling and confusion. So let's get started. So um, so we're going to talk about some loosely defined concepts here that that are based in theory, and they'll help us get started. And we'll start to use some internet online tools to take a look at circuits first before we dig into the physical thing. Um, every circuit has a voltage source, and voltage is measured in volts. And we're going to talk a lot more about this later, but basically voltage provides the energy that allows the electrons to pass through the circuit. Um, if we have a complete circuit, there's a path for electrons to go through, and electrons will flow from the negative terminal through some components and then back to the voltage source. In that case, we say the circuit is closed or that we have a closed circuit. So electrons only flow when we have a closed circuit. That is a path that goes from the negative terminal to the positive terminal. So now if there's a voltage and the circuit is closed, then current is going to flow through all the components of the circuit. And so that flow of electrons is called current. And we always use the word through to describe current because current passes through the components of a circuit. Um, Wires or other conductors of electricity, good conductors, like the buses on the breadboard, they provide the path for the electrons to flow from one component to the other component. And although electrons in a circuit flow from minus to plus, when we draw a circuit and when we talk about circuits, we define current as flowing in the opposite direction from positive to negative. That's called conventional current. Um, the units that current is measured in um, is amperes, and we'll talk more about current in detail a little bit later. We can control the current using components called resistors. So resistors um, oppose the flow of electrons, and therefore we can use resistance to control current. The higher we make the resistance, the less current will flow, provided that the voltage stays the same. Um, Electrons lose energy as they pass through the resistor because the energy um, of the electrons has got to go somewhere, and we're opposing the flow. So that energy gets dissipated as heat, and we'll talk more about that as as we go forward. Resistance is measured in units of ohms, and when current flows through a resistor, um, the electrons lose energy, and we can see the energy that's being lost by electrons flowing through the resistor by measuring the voltage across the resistor. So when we're talking about voltage, we always use the word across to describe voltage because that's how we measure it. We measure it across a component between 2 points. When we're talking about current, we always say through the current, through a component, because current is about the flow of electrons that go in and come out. Okay, so when the voltage across a resistor increases, the current through it also increases. So this is a linear relationship, and the relationship is given by the famous expression Ohm's law, which often is expressed as V equals IR, but you can rearrange the expression to solve for I, or you can also rearrange the expression to solve for R. No biggie. Um, because voltage exists across a resistor, when we want to measure it, we simply place our voltmeter probes across it to measure the voltage. Current, on the other hand, flows through a component. And so to measure current, we have to place an ammeter in series with the resistor. And this means we need to break the circuit connection to do that. And that's often just inconvenient. So most of the time, we're just going to use Ohm's law to calculate the current instead of measuring it. We may do it once just to see what happens, but measuring current is inconvenient in a number of ways. So one is that you have to break the circuit, but the other is that if you do it incorrectly, if you make a mistake about where you stick the probes, um, you may inadvertently short out a power supply and blow the fuse inside your multimeter, and then never be able to use the multimeter to measure current again until you've replaced the fuse. Um, so circuits circuits have a theoretical representation that is something we draw in our lab notebooks, and that will be a schematic representation. And there's a piece of software online called Multisim Live where we can actually simulate the operation of a circuit we want to build and make measurements on that circuit. And then there's also an online tool called Tinkercad um, that allows us to actually build the circuit on a breadboard, a virtual breadboard, virtually build it on a virtual breadboard with virtual resistors and virtual power sources. But the idea is that um, if you're someone who has difficulty seeing how things go together on a breadboard, using Tinkercad is helpful. So so let's take a look at some of this. Um, so in your lab notebook, you will draw a circuit diagram, and for all your homework assignments, you'll draw a circuit diagram, and the circuit diagram should be fully labeled. And so this is a fully labeled circuit diagram. So here's our voltage source. Here's a resistor that we call R1. So we give names to these components so that we can keep track of them. And here's R2, and here's R3. And recall the current flows through these components, and it flows from plus to minus. And so that's why these current arrows, so current is represented by I in this diagram. So, so that's why the arrows of current are all facing in that clockwise direction. Is because that's the direction the current is flowing. The electrons are flowing in the opposite direction. And each resistor has a voltage across it. And so if this is R1, we label the voltage across R1 as V1, and V1 has a polarity, and the polarity should be consistent with the direction of the current. So if the current is going from left to right, that means To the left, um, the voltage polarity is plus, and to the right, the voltage polarity is minus because current flows from plus to minus. And the same thing here, so only this resistor is oriented vertically, so the current is flowing from plus to minus here. And finally, through this last resistor, the current is flowing now to the left because it's flowing from plus to minus. The flow of current is always from plus to minus. Okay, so so we label voltage with a V, we label currents with an I, and every time we label a voltage with a V, there is a polarity associated with it, a plus side and a minus side. And every time we specify a current, we place an arrow in the diagram to show the direction of the current. And your textbook will have that arrow going in the opposite direction. Okay, that's just the way it is. Okay, the textbook is great except for that one thing. They draw the arrow in the other direction. They deal with electron flow instead of current, but that doesn't change instead of conventional current, but that doesn't change anything in terms of like the quantities we calculate and so forth. Okay, so voltage is measured in volts, or it could be millivolts, or it could be kilovolts. Current is measured in amperes, or it could be milliamperes, which would be 10 to the minus 3 amperes, or microamperes, which would be 10 to the minus 6th amperes. Resistance is measured in ohms, or it could be kiloohms, which would be 10 to the 3rd ohms, or megohms, which would be 10 to the 6th ohms. So always label your diagrams. You should have polarity, direction, and the symbols that represent the values. And then we can apply Ohm's law to every resistor in our diagram. But fundamentally, like for lab 1, this is going to be our design. Let's take a look at some of those online tools. So let's go here. This is Multisim Live, and create a circuit. And so our tools are over here on the left, and every circuit we build has got to have this symbol, which is a ground symbol. That ground symbol is necessary for the simulator to do its thing. And we'll find when we use the 82 as a voltage source, we'll always be using a ground connection there as well. So okay, so I've got a ground symbol, and generally speaking, the ground symbol is something that we connect to the negative side of our voltage source. Now, and we'll put that in a second, but let's grab some resistors. So there's a resistor, and I'm going to copy that, and now I have another one, and now I'm going to rotate that, and now I'm going to take this, and I'm going to copy it again, and I'm going to put it down here. So those are our resistors, and we can connect them together. So boom, so there's wire, and here's a wire. Wire has 0 resistance, and you see the resistance values have been assigned to each of these resistors, R1, R2, and R3, and this is 1 k ohm, 1 k ohm, 1 k ohm, means each one is 1,000 ohms, and we'll take the end of this one, connect it to our ground symbol, and now we need a voltage source. And none of these voltage sources look like what I'm familiar with, but when I hover over that, it says, oh, sources. So let's click on that, and yep, there we go, DC voltage. So I'm going to take that and put that in the circuit, and now connect. connect everything together, and now I have a complete circuit. The long end of the voltage source, so this is the long end and this is the short end. The long end indicates the positive voltage. If I double click on this, this window opens up here and I can put in whatever voltage I like. So let's work with 5 volts. In fact, let's work with 5 volts. That's fine. So working with 5 volts, and then I'm going to make this 2k ohms. So over here I can put in 2k ohms, enter, and here I'm going to put in 5k ohms, 5k ohms, and down here I'm going to put in 3k ohms. Okay, so now I have 3 resistors. R1 is 2k, R2 is 5k, and R3 is 3k ohms. And I can start this simulating by clicking this run button here. But there's nothing to see because I haven't attached any instrumentation to this at all. So let's stop that. Okay, so to get the components back, we want to stop the simulation. So we press the stop button, and now the simulation is stopped. And we need to be able to make some measurements here. So there is this item in the in our toolbox, which says analysis and annotation. And I click on that and it will tell me the voltage or the current or the voltage and the current. And then there's something called the voltage reference, and you'll see why in a second. So this voltage and current, so recall that voltage is always measured across something between 2 points. And so let's put this here. Okay. So I put that there, and let's click off of that so you can see. And this says, oh, it's 5 volts, but it can't tell me the current because I'm not simulating. And so let's simulate, and now it says 500 microamperes. Okay, so 5 volts, 500 microamperes. But recall that when you use your DMM, you have to put a black probe somewhere and a red probe somewhere. And the way this measurement system works is that the black probe is tied to ground here. Now let's see if we can't get around that. So this is only telling us what voltage is across our supply. But so let's stop the simulation. But they do provide this thing called the voltage reference. So if I take that and I poke that in there, now I click this. Oh, what did I do? I copied it. Okay. So ref 1. So if I pull that out, now put that in there. Now ID 3, that's not helpful. Let's try to grab another one. So now I'm going to grab this one and put that one there. That says 5 volts. What if I put that there? And now, yes. So now it says 1 volt. So this is where I stuck this is now the reference point. So yeah, it's a little weird. Let's go back and try to do this right. So we're going to stop this. I'm going to delete that. I'm going to get rid of this reference, delete that because I don't think we need it. I'm going to delete this. Okay. So now when I did that, I ended up with this that I could drag here. So, and that's where the 1 volt comes from. If I were to take it and drag it here, now I have to do the simulation again, but let's go back. If I put it here, it should tell me 5 volts. So this is going to be the red probe, and this is going to be the black probe. And let's run this. And now it says 5 volts. Now, can I grab this and put it someplace else? Nope. I've got to stop and now move it here. And now run this here. And so what this is telling me is the voltage across R1, which we would call V1, is 1 volt. And if I want to know what V2 is, I would move the black probe down here and the red probe, even though on our screen it's not red, here, and that will tell me the voltage across this resistor. And I can stop it again, so that would be V2. I can put my black probe there and my red probe here and run it, and that will tell me V3. Okay, so that's a little bit about how to get started. With Multisim. And so we built a circuit, has 5 volts and 3 resistors, so 2K, 5K, and 3K. Let's see how we might do the same thing in Tinkercad. So for all these things, you need to make an account and so forth. But so, oops, I say create a new 3D design. That's bad. That's bad. Go back. I have no interest in making a 3D design. I have to click on circuits, create a new circuit. And so now in this system over here, I have resistors, and I could take the resistors out. 1, 2, 3. Those are my 3 resistors, and you see they look like physical resistors, right? So to build this circuit, I need 3 resistors, and I also need a voltage source. So let's see if I can't find a voltage source. So let's switch over so that my face is not in the screen at all. And so we need a voltage source. So let's see what's in this components location. Oh, wrong thing. Let's see what's in this component drawer here. Okay, so there's a breadboard. So I can put that out here. And I'm going to rotate it so that it's familiar. Okay. And now I need a battery now. They have I need a voltage source. They have a coin cell, they have a 9-volt battery, they have a 1.5-volt battery, but they also have a voltage source, but you have to look at all the components and then go down and find the power supply. Oh, power supply. So now we can put that here. And so the voltage is 5. Yep, okay, good. So now the negative side, what we'll do is we will bring that to the negative power bus here on the breadboard, and we'll take the positive side, we'll put that to the positive power bus. Okay, so all of these, you can see that when I hold the mouse over a hole here, all of those holes turn green. It means all of those are connected together. And the same thing here, all of those holes turn green. It means all of those are connected together. And if I keep going right, you can see the way the buses work. Each one of those buses lights up as green, and all of those green holes are connected together. Okay? So now, in our circuit diagram, we had two resistors that are horizontal. So I'm going to horizontal that one, and I'm going to horizontal this one. Whoops, too far. Okay, so now I've got this one, and I'm going to place this across the void, like that. I'm going to take this one, place that one across the void. I'm not sure where I want that one to go because it's going to depend on where this one goes. So I put that one there. So these two resistors, so this is R2 and R3, whoops, R2 and R3 are connected together by this bus here. Now I need to move this R1 down so that now that's connected to R2, and now I just need to make connections from the power supply to my circuit. So this is going to go there, so that's my plus side of my power supply, and that is going to go there. That's the minus side of my power supply. And then the resistors had different values. So this was 2K, this was 5K, and this was 3K. Okay, so let's just check 2, 5, and 3. Okay, so now to make our voltage measurements, we need a multimeter. So I'll click on this, and so there's the multimeter. It's in voltage mode, and so there's the negative side is there. So that's a black probe. Which is unfortunate because I'm going to put the red probe here, which makes them cross like that. I wonder if I rotated this. So, but then I can't see how they're connected, and I, it may turn out upside down. Now I can see that how they're connected, but the result might still turn out to be upside down. Anyway, let's see. So I should be able to start the simulation now. Yeah, and this says 1,000 millivolts. So 1 volt across R1. Stop simulation. So basically, yeah, let's turn this around. Okay. Start simulation. Yeah, so I have 1,000 millivolts there, which is 1 volt. Not all of these tools are going to follow the rules that that we will follow to express values. So if I want to move this, I have to delete these wires and then put them someplace else. But basically, you get the idea. This system allows you to build the circuit the way it looks on your breadboard, which is especially helpful if you need practice at getting used to how to connect things together on a breadboard. Um, but the standard way of looking at a circuit like this is this way. And neither one of these is going to give you a representation that looks like what you have in your textbook, which is where they take a voltmeter and they put it directly across a component. Take voltmeter, put it directly across a component, or take an ammeter and break the circuit and put the ammeter in. Okay, so let's move on then. So now we want to do some work at the bench. So let's look at a little checklist here that I put together. So back to my screen and back to here, and then here. So those are online tools, and basically what we're going to do to set up for just about every lab is we'll have the breadboard connected to the Analog Discovery 2. We'll have the Analog Discovery 2 connected to a PC. We'll have the waveform software running and recognized and recognizing the 82. We'll have a DMM. The DMM is always a great sanity check to have at your side. If you're not getting what you expect, and and part of part of what we do that's most important in the lab is doing calculations to know what to expect. The DMM can help us check things out. We're going to have resistors, so we can build our circuit on the breadboard, and then some tools. So to get the resistors cut so that they can go in the breadboard, you're going to need some scissors or a cutter of some kind, and at some point I may be able to supply you with wire cutters, but I don't have them right now, so we're going to do the best we can. So here's some scissors, and here's our resistor packs, and here's where we left off last time. So if you recall, with the let's take a look at the Analog Discovery 2 on the screen. So screen view, let's minimize this and minimize this. The Analog Discovery 2 opens up with this welcome window, and I don't know why I can't make that any bigger, but I can. And the welcome window has all of these buttons here that will allow you to implement particular different types of test equipment. So last time we used supplies, and by clicking up here, so by clicking up here, I can have either tabbed windows or I can have docking windows, or I can undock everything by going up here to settings, options, and saying have my instrument windows separate, which is the way I like it. Because otherwise, this power supply that has just 3 buttons on it can take up like a huge amount of screen space, and it's really not necessary. And I'd like to be able to access these buttons at any time. And then so that's my power supply, and then I need a voltmeter. I click on that. So here's my voltmeter, and and so and so for this first lab, this is basically all we need, um, is the voltmeter and the power supply. So now let's go back to the bench. So back to the bench. So I've got 2 resistors in here. Now in my list of tools are things like tweezers or forceps or pliers. Um, for folks who have some difficulty, have maybe big fingers, or have difficulty finding holes. So having the tools can help you make connections more precisely, and maybe take some of the frustration out of it. Um, so let's zoom in on this a little bit if I can. Yeah, there we go. So our analog discovery is up here, and we have taken the negative side of channel 1 and channel 2 and just put in wires to connect those to ground. That was what we did in the last video, and these wires here we put in to measure the power supplies, but now that we verified that the power supplies work, these are pretty much not necessary. And just like I did in Tinkercad by using the buses here on the left to provide the power, that's what I'm going to do here. So I'm going to take my V plus, which is the 4th hole down, and connect that to the red bus over here. And then I'm going to take make a connection to ground. So ground is the 3rd hole down. So that's that triangle icon. And I'm going to make a connection there, and then bring that over to the blue bus. So now, we're going to be energizing when we turn the power supply on this negative bus and this positive bus. So this is the way we set up, and then we're going to have the positive bus connected to one of our resistors here, and then this resistor is connected to this resistor, and now I'm going to need a 3rd resistor. So I'm just going to snip one out here. I use my wire cutters because they're much faster. Bend the component over like that, and And now use my tweezers to put them in the holes. And now I need to connect to the negative side of my supply from here to the negative side of the supply. So I grab a wire and do that. And sorry, that wasn't on camera. So I put, let's do it again. Okay, so now we're going to build our circuit and and we started off with these two resistors in series like before, from before. Now I'm going to connect to the positive power supply. Now I'm going to put a third resistor in. This is my R3 in the diagram. So now I have R3 in the circuit, and now the only thing I have to do is connect from R3 using a wire to ground, which is the negative side of the power supply. And so that's how I built it. So that's all I'm going to do at the moment. So we went through some theory, and we went through simulate the how to simulate our circuit for Lab 1, and using online tools. And now I've showed you how to use the breadboard and actually build the circuit on the breadboard, except we don't have specific component values yet, so we still have to do that. We still have to make some measurements and do some calculations, and we'll do that in the next video. Okay, thanks.